Vertical hyperbola. Here is a hyperbola with transverse axis coincide with the y-axis.
And the conjugate axis coincides with the x-axis.
The center is at the origin. The upper vertex is a distance a from the center.
And the lower vertex is at distance a also. The two vertices are along the transverse axis.
And at distance c from the center along the transverse axis are the two foci.
Plot the points with distance b from the vertices. Here in the lower vertex, draw points with distance b. Now, we are going to draw the asymptote lines passing the points with intersection at the origin. Here is the graph of hyperbola with transverse axis coincides with the y-axis.
The equation for this hyperbola is y squared over a squared minus x squared over b squared equals 1.
Note that y squared in this case is the minuend while x squared is the subtrahend.
For hyperbola with transverse axis coincides with the x-axis.
The equation is x squared over a squared minus y squared over b squared equals 1.
X squared is the minuend while y squared is the subtrahend.
For the coordinates, the center is 0, 0.
For the foci, the upper is 0, c, and the lower is 0, negative c. For the vertices, the upper is 0, a, and the lower is 0, negative a.
For the equation of the asymptotes, this one leaning towards the right is y equals a over bx. The other asymptote leaning towards the left has the equation y equals negative a over bx.
Example 16y squared minus 9x squared minus 144 equals 0.
Transpose 144 to the right, so 16y squared minus 9x squared equals 144.
Divide both sides by 144.
Reducing each term to the lowest fractions, we have y squared over 9 minus x squared over 16 equals 1.
So a squared equals 9 and b squared equals 16.
To simplify this, we are going to take the square root, so a equals plus n minus 3 and b equals plus n minus 4. We have also c squared equals a squared plus b squared.
From the values we have c squared equals 9 plus 16, so c squared equals 25.
Getting the square root, we have c equals plus n minus 5.
This is our value for the distance from the center to the foci.
Let's plot the points on the Cartesian plane.
Let's have first the vertices. The first vertex is 0, a, or 0, 3.
The second vertex is 0, negative a or 0, negative 3. Next is the foci. The first is 0, c or 0, 5.
The second is 0, negative c or 0, negative 5.
To the right of the upper vertex, plot the point 4, 3.
On the left, plot the point negative 4, 3. On the lower vertex to the left, plot the negative 4, negative 3.
Then to the right, plot the point 4, negative 3.
We can connect these points ready for the asymptotes.
The rise and run or the slope of is 3 over 4, so the first asymptote has the equation y equals 3 over 4, x, forming a diagonal passing negative 4, negative 3 the origin, and 4, 3.
The second asymptote has an opposite direction to the first asymptote, so the equation is y equals negative 3 over 4, x passing the points 3, negative 4, the origin, and negative 4, 3.
So this is the graph of the hyperbola 16y squared minus 9x squared minus 144 equals 0. The two asymptote lines serve as guides to the direction of the opening of the hyperbola.